simple event or not? Now, in a simple event says only one outcome do you expect. Rolling a dice, getting a 4. Rolling a dice, getting a 6. They're simple events, one outcome. Rolling a dice, getting an even number, you can get 2, 4, or 6, is not a simple event. So a simple event says you expect one outcome. For quality control, you randomly select a computer chip that has been manufactured. Event A is selecting a specific defective chip. Is this a simple event or not? You're looking for the defective chip or not? Yes, simple. Only one thing that you're checking for at a time. Rolling a 6-sided die, event B is getting at least a 4. Simple or not? Not. At least a 4 says, what can I get? At least a 4. So 1, 2, 3, 4. At least or at most? At least. So is this at least or at most? At most. Be careful with the at least, at most. This is at most a 4. What's at least a 4? This is the least one that could happen. 4, 5, 6. Is this a simple event? Did I ask for one thing in return? No, I asked for 3 things. Not a simple event. A simple event will return one thing. When you do at least at most, think money in your pocket. If you have at least $4, you have 4 or more. If you have at most $4, that's the most you have. It's $4. If you think money in your pocket, it seems to put it into perspective. Okay. Now, you decide this. Take a minute and you decide. Read 1 and 2, and you decide if it's a simple event or not.
Do you want us to answer this quietly in our notebooks, or do you want
Just hold on to your answer, and we'll talk about it in about 30 seconds. Okay. Simple or not, you want one thing returned, one thing you're checking on. So your student's age is between 18 and 23 inclusive. What does inclusive mean, by the way? All the numbers in between and including the outside ones. So you're looking for 18, 19, 20, 21, 22, 23. Simple event or not? Not. You want too many things back. The event you're looking for is the student's age is 20. Simple or not? Simple. You want one thing back. One outcome. Now, your types of probability. You basically have 2 types. You have your theoretical, you have your empirical. The theoretical, actually, you also have a subjective one. You have your theoretical, which is sometimes called your classical. Some books call it classical. Most books say theoretical. Theoretical is by theory. It has been proven over and over and over and over that every time you flip a coin, a fair coin, the probability of heads is 1/2. Okay? That's theoretical. Empirical says if I flip this coin 10 times and I get 6 heads and 4 tails, it didn't come out to be 1/2, 1/2. That's my empirical, my experimental, the one that you perform. And your law of large numbers will get you closer and closer to your flipping your coin. We're going to do this tomorrow. We're going to flip coins in here and then pull all our answers together and see if we get closer to the theoretical probability. It's a good way to kind of understand that. In a theoretical, your probability is never going to change. Each outcome in your sample space is equally likely to happen. And theoretically, your probabilities do not change. It's always going to be 1/2 when you flip a coin. If you flipped a coin 10 times and you had 9 heads in a row, on the 10th time, it's still probability of 1/2. If you do anything like in Over time, you prove it. It only takes one exception to disprove a theory. Just one. Your probability is written in the number of outcomes over your total number of outcomes. In other words, your part over your whole. How many met this situation over how many were in your sample space. Part over whole. This is like your relative frequency. So your relative frequency is like your probability. Your area under the curve is like your probability. And it always adds up to 1. Your probabilities also go from 0 to 1. They can never be negative. It can never be more than 1. 0 tells me impossible. If today is Wednesday, the probability that tomorrow will be Saturday is
impossible.
Impossible. 0. If today is Wednesday, the probability that tomorrow will be Thursday is
Possible.
1. If tomorrow's Thursday, right? If today is Wednesday. So impossible says this won't happen. 1 says this will always happen. This is certain that it will happen. I have marbles in a jar. I have 5 reds, 3 blues. What's the probability of getting a red?
8.
5 out of 8. What's the probability of getting a yellow?
0.
0. What's the probability of getting a red or a blue? 8 out of 8 or 1. There's your certain. There's your impossible. You can't get a yellow if there's no yellow marble, right? A red or a blue. So that's in there. You'll always get a red or a blue when you pick a marble from this red or blue jar. Okay? So, Okay. So you roll a 6-sided die. Find the probability of each event. What's the probability? First of all, do it this way. You roll a 6-sided die. What are all the possibilities? What's the outcomes for this?
3, 4, 5, 6.
Yep. 1, 2, 3, 4, 5, 6. Whoops. 2 6s. My die is loaded. Keep laughing. I'm going to throw the eraser at you. 1, 2, 3, 4, 5, 6. You have 6 possible things. Bottom number is 6. How many 3s do we have up there? 1.
Oh, it's 1.
1 out of 3. Probability of rolling a 3 is 1 out of 6. What's the probability of rolling a 2?
Oh.
1 out of 6. What's the probability of rolling a 5? 1 out of 6. Okay, what's the probability of rolling a 7?
0.
0. This can't happen. What's the probability of rolling less than 5?
4.
4. This is less than 5, this is less than 5, less than 5, less than 5. Easiest way is to mark it. I have 1, 2, 3, 4, 5, 6. Going for the 7. This guy, this guy, this guy, this guy, it's 4 out of 6. Probabilities, we reduce to lowest terms. In the event, yeah. What? Yeah. Okay. So when you do this, most of the time, if you have any other steps in your probabilities, don't reduce them to the end. Because if we want to say what is the probability of rolling this or this, then when we add them, we want the denominators to be the same. So at the very end, go back and reduce them. What's nice about when you do them in your calculators, you can just go to math fraction and it automatically reduces your fraction. And if we do probabilities in decimals, because a probability can be a decimal, this is my rule of thumb. Probabilities go 3 decimal places. Rule of thumb. If you're going to divide something out, go 3 decimal places. You don't want to cut something down and say it's 0.5, because that's exactly half. If it's 0.52, it's a little bit more than half. So, rule of thumb is 3 decimal places on the probabilities. Okay, you guys try these. Jot them down, and then we'll talk about them. Anybody not know what a deck of cards? Anybody not play cards?
52 Pickup was my favorite game.
52 pickup. Usually I get 1 or 2 that in my class that doesn't play cards. I have a deck of cards on paper if anybody needs them.
Can we play blackjack? Like, I know it's like this on account. Can we actually play it?
On your own time, yeah. I don't know. Can you play?
I'm pretty decent.
Pretty decent? Why is it that they say if you get 15, you have to hit. If you get 16, you have to stay. How do they make those rules? Who comes up with them?
It's by probability.
By probability. So why? What is the difference? Like, what stops you from staying at 16 versus 15? Or where does probability come into play? Because why?
Because when you're at 15, to get a 7 or above, it's not that common. It's not rare. Well, it's not common, but like to get when you're 16, to get exactly 6 or not exactly 5 or something like that, it'll be extremely hard. So.
Well, 5 or less, yeah, because you're having less cards to choose from. So as Joe and as Darian say, probabilities. This is your probability. What is the probability of getting a card 7 or higher, or 6 or higher? And your ace can go either way. So your ace can be a 1 or it could be an 11. So these are where your probabilities come into play. Question, guys?
Wait, I'm sorry, I was telling you.
Yeah, you're all sidetracked today. Okay.
I'm sorry, I love you.
How many cards in your standard deck?
52.
52. Bottom number, 52. How many suits in your deck?
4.
4. How many in each suit?
13.
13. Okay. What is the probability of selecting a 7 of diamonds?
1 out of 2.
1 out of 52. What is the probability of selecting a diamond?
13 out of 52.
13 out of 52, or how many suits is that out of your total? 1 out of 4. That's what that reduces to. What is the probability of selecting a diamond, a heart, a club, or a spade? 2? 1?
No, yeah, it's 1.
That's the whole deck.
50 out of 52?
Yeah.
Jokers don't count in your deck. There are the extra cards. So go back a step. Cyphers, how many would you have? 52 out of 52. When you pick a card, what's it going to be? This is your certain condition. It's going to be a diamond, or a heart, or a club, or a spade. That's the only thing that can happen in your deck of cards. So you are certain to pick one of them. What is the probability of picking a diamond or a heart?
46 out of 52.
26 out of 52, or half of your deck, right? Isn't half of your deck red, half of your deck black? So what's the probability of picking a red? Half.
26.
26 out of 52. Half. What's the probability of picking a black heart?
26.
26 out of 52. Half of your deck. Right?
It's not like a quiz or something. Would you want us to put it down in the broken down form, or like?
You have to reduce them. You have to reduce them to lowest terms. But like if we're going to work with probabilities, like do a whole bunch of things, don't reduce to the very end. Okay. Empirical. Shh, ladies. Empirical, or they sometimes call this statistical probability. Mostly it's empirical. And the way you remember this is empirical E is your experimental. Experimental, guys. Experimental probability. This is what happens when you perform the experiment. When you do an experiment, it's not always going to work out to be the theoretical. It's going to be whatever the dice rolls, whatever the card you pick, whatever it is. But you still take the frequency part over whole. So, for instance, I have a pond. It contains 3 types of fish. Oops. Bluegills, redgills, and crappies. Each fish in the pond is equally likely to be caught. You catch 120 fish and you record each type, and you release the fish back into the pond. Here is your frequency of what you caught. Oh. Here's your frequency of what you caught. What is that too? Okay. So what is the probability? Now, shouldn't it be equally likely? Shouldn't they all have been 40, 40, 40?
Yeah.
Well, you'd like for me to explain.
Okay, explain to me, Darian, enlighten me.
Alright, well, it should be theoretically.
Ah, theoretically.
That's the key word of the day here, guys.
Theoretically, it should be 1/3, 1/3, 1/3. What? Right?
Yeah.
Okay,
Yeah.
but
Due to the experiment,
yes.
it seems that they have caught different types of fish.
So experimentally is also our empirical. These are your empirical probabilities. So therefore, empirically, what is the probability that you caught a bluegill?
39.
39 over 120. Now look, this is your frequency of that happening over your total frequencies. The frequency of one thing happening over the total. Okay, so theoretically says, yeah, this should work. I should get 1/3, 1/3, 1/3, but empirically, experimentally, you're not going to get 1/3, 1/3, 1/3. It may work out that way, and it may work out that if you did this 1,000 times, you're going to get closer and closer to your 1/3, 1/3. That's called your law of large numbers. So an insurance company determines that in every 100 claims, 4 are fraudulent. How do I write the probability of being fraudulent?
4 out of 100.
4 out of, yeah, 4 out of 100. Okay? What is the probability that the next claim you choose will be fraudulent?
4 to 100.
5.
4 to 100.
4 out of 100. Your probability is going to stay the same. That's their theoretical. They have determined that 4 out of 100 claims are fraudulent. Okay? All right. We're almost there, guys. Because I want to hit this one, because tomorrow this is what we're going to deal with. Law of large numbers. As an experiment is repeated over and over, your empirical probability approaches your theoretical probability. Your range goes from 0 to 1, and your probabilities can be in the form of a fraction, a decimal, can be a percent. When you say, what is the probability of rain today? Do I say 1 out of 3? I say 30%, right? So percent works for a lot of the probabilities that we do. Percent from our tables, from our charts, those were your probabilities. Percentiles, probability of something happening. So you sample 100 employees. The results are random. If you randomly select another employee, what is the probability that employee will be between 25 and 34 years old? I didn't get the
233 out of 1,000.
between 25 and 34, 366 out of 1,000. Okay. So when you do your probabilities, you're still going part over whole. What is the probability that they will be between 15 and 24? 54 out of 1,000. What is the probability that they will be 65 or older?
42 out of 1,000.
Okay, what is the probability that they will be less than 65?
Quick math here. 900 and
958. Good. How'd you get that, Lizzie?
You just subtract 42 from 1,000.
Good. This is called, did anybody know what this is called? Complement. This is called the complement. Not the complement I, complement E. Everything but that. So if you're looking for the one odd thing out, subtract it, and you'll get everything but that. Okay. Is the vocab's in the book?
I Google.
It's in the book, and so on your notes as well.
Nope, when you go so fast, like I was kind of ready. You just like scroll past it.
Oh, I'm sorry. You can tell me to go slower. These are all on, you know the note page that I gave you? They should be on there as well.
You gave us one today.
No, yesterday. Monday.
It's on like
Okay, subjective. One last one, guys. Subjective. Subjective probability results from your intuition, your educated guess. Someone's going to say, what's the probability that that these kids are all going to go to college? Well, theoretically, we can look up what the probability is when kids have a certain grade point average. But you can look at them and say, I know this kid's going to go. I know what's in my gut. This kid's a definite college kid. So if you can throw in your gut reflex on that, that's called subjective probability. When you listen to the weather, each weatherman has a different forecast. Somebody says 40%, somebody says 30%. They look at the weather trends and then they say, well, I've seen this weather trend, and 9 times out of 10 when it happens, it rains. So I feel the probability of rain's a little bit higher. Yes?
Why? How does it make any sense? How is a farmer's almanac usually more correct than the did you ever notice that?
I always notice
Every
that.
time I watch weather on the news, it's always wrong.
But with global warming, I don't know how that comes
plans out
in.
the weather for the entire year. Farmer's almanac.
Okay. All right, so tomorrow, guys, we'll finish this up, and then we're going to do a little experiment on flipping a coin.
There's a phone could use that time.
Thanks, bro. I just want to go pool.